Dear students, now we discuss Fourier series of even and odd functions. Definition: the function f is even if f of minus x is equal to f of x for all x in the domain of f. Next definition is odd function. The function z is odd if g of minus x is equal to minus g of x for all x in the domain of z. Now, familiar examples are cosine and sine. Okay, cosine is even, whereas sine is odd function. Okay, we know that cos of minus theta is cos theta, sine of minus theta is minus sine theta. Now, there is important result. So, when we consider even function, then its Fourier series will contain the terms of cosine only. Similarly, if we consider Fourier series of odd function, there are terms containing sine only. Okay, so let us see the result. So first, the Fourier series of an even function of period 2L is a Fourier cosine series. Fourier cosine series means the Fourier series containing cosine terms only. F of x equal to a0 plus summation an cos n by x upon L n from 1 to infinity, where a0 is 1 upon L. Note that it is not 1 upon 2L, it is 1 upon L. Integral lower limit is 0, Okay, so 0 to L f of x dx. Okay, so here function f is uh, even function. So we are getting this expansion. Okay, so if function is even, then f of minus x is f of x. So this integral from actually a naught is given by 1 upon 2l integral from minus l to l f of x dx. Okay, and when we consider this from minus l to l, it will be from minus l to 0 plus from 0 to l. Okay, and then in first term we use change of variable. Okay, so we replace x by minus x, so that this is f of minus x, but f of minus x is same as f of x, and dx will be minus. Okay, there will be minus dx. Limits will be here it will be L and here it is 0. Okay, so everything is sign of everything will change. Okay, now because there is minus dx, we can write it as, instead of L to 0, we can write 0 to L. Okay, so first term is also same as this one, that means integral 0 to L f of x dx. So we have two times and that 2 gets cancelled here. Okay, so we get 1 upon L integral from 0 to L f of x dx. Okay, so these two terms will be same. Okay. Same thing happens for an. An is earlier it was 1 upon L, now it is 2 upon L. Okay, so 2 upon L. Integral again from 0 to L. F of x cos of n by x by L. Everything else is same. N is 1, 2, and so on. Okay, so this is for even function. Now, similarly, we have the result for odd function. So, second result. The Fourier series of an odd function f of period 2l is Fourier sine series. Fourier sine series means Fourier series containing sine terms only. It is f of x equal to summation bn sine n by x by L n from 1 to infinity, where bn are given by 2 upon L integral from 0 to L. So I am using different color where you will find change from previous theory. Okay, so earlier we were having 1 upon L integral from minus L to L. Okay, so these are the changes shown in different color. F of x sine n by x by L dx, n is 1 2 etc. Okay, we are going to see one more important result. It is about uh, addition and scalar multiplication of two functions. Okay, so if we have two functions f1 and f2 with same period, and suppose we have um, Fourier expansions. So what about the Fourier coefficients of f1 plus f2? Okay, so this result says that we just have to add Fourier coefficients of f1 and Fourier coefficients of f2, corresponding coefficients. Okay, uh, then we get Fourier coefficients of f1 plus f2. Okay. Similarly, if we have scalar multiplication, say 2 times f, okay, or in general c times f, then Fourier coefficients of this new function cf are just c multiplied by Fourier coefficients of f. Okay. So let us see the result. Suppose f1 and f2 are periodic functions the period of f1 and f2 need not be same. Okay, so simply we need periodic functions. The Fourier coefficients of a sum f1 plus f2 are the sums of corresponding Fourier coefficients of f1 and f2. The Fourier coefficients of c times f, c is constant. Okay, c times f, f is periodic function, c is constant. So Fourier coefficients of cf are c times the corresponding Fourier coefficients of f. Okay. Now let us solve example. This is sawtooth function. Okay, when we sketch this function, then we can realize that it looks like sawtooth. Okay, so let us write down this. The question is find Fourier series of this sawtooth function, it is given by f of x equal to x plus pi, pi is constant, if minus pi less than x less than pi, and f of x plus 2 pi is same as f of x for all reals. Okay, that means this is periodic function of period 2 pi. So L is pi in this case. Okay, so first we scale this function and we see that it looks like sort of. Okay. So function is x plus pi between minus pi to pi, and it repeats. Okay, it is a periodic function. So this is horizontal axis. Uh, we have 0, minus pi, pi. Okay, so here between minus pi and pi, the value of function is x plus pi. Okay, so x plus pi is a straight line. Okay, y is equal to mx plus c, like that. Okay, so m is 1. So it is making angle of 45-degree with horizontal axis. Okay, so I'm trying to sketch. Okay, so it should look like this. Okay, note that things are not defined on boundaries. That means at minus pi and pi. Okay, so nothing is there at this point. After this, this curve will repeat. That means from minus pi to 3 pi. Okay, so here if we have 3 pi, then the same curve will repeat in this case. If this is minus 3 pi, we will have same thing. Let us sketch. Okay, so okay, so actually this is not part of curve, but if we sketch, it will look like sawtooth. Okay, so this function is called as sawtooth function. uh, it is combination of two functions. You can say that it is of the form f1 plus f2. Okay, where f1 of x is x and f2 of x is pi. Okay, so it is sum of two functions. Okay. We have f equal to f1 plus f2, where f1 of x is x and f2 of x is pi. Okay. Now, f2 is constant function, so its Fourier series will contain only one term, that is pi only. Okay, so this will be a0. Okay, all other ans are 0, bn's are also 0. Okay, so it contains only one term. Okay, the function f2 is constant, therefore its first Fourier coefficient is pi, and all other all others are 0. That means all other Fourier coefficients are 0. Okay. So when we find Fourier coefficients of f, then we have to add corresponding Fourier coefficients of f1 and f2. Okay. Now we have seen that for f1 there is only one Fourier coefficient which is non-zero. That is first coefficient. Okay. So a0 of f1 should be added to a0 of f2, and all other terms are from f2 only. Okay. Now the function f1 of x equal to x is odd function. Okay, because f1 of minus x is minus x, and that is minus f1 of x is odd function. Therefore, we will have Fourier sine series. Okay, that means all an's are 0. Okay, therefore an equal to 0 for all n, and bn, we have bn to be 2 upon L. L is pi here. Okay. So we should note that L is pi here. Okay. So it is between minus pi to pi. So this is periodic function of period 2 pi. So L is pi. So 2 upon L means 2 upon pi. Integral from 0 to L, that is 0 to pi. Function f1 of x into sine n pi x upon L. L is pi, so n pi x upon pi. That is sine nx dx. And so this is x sine nx dx. Now we use integration by parts. So this is 2 upon pi. First term is x, integral second, integral sine nx, it is minus cos nx upon n, limits are 0, pi, minus integral derivative of first is derivative of x, that is 1, integral of sine nx, that is minus, so this becomes plus cos n x upon n dx, and this is 2 upon pi. Here if we put upper limit, then it is minus pi cos n pi. Cos n pi, we know cos n pi is minus 1 raised to n. Okay, so if n is 1, cos pi is minus 1. If n is 2, cos 2 pi is plus 1. Then cos 3 pi is minus 1, cos 4 pi is plus 1, etc. Okay, divided by n. Then lower limit 0, x equal to 0 is 0. Okay, cos 0 is 1, but this is 0. Then this one, integral cos nx 1 upon n is there. It is sine nx upon n. Limits are 0, pi. If we put upper limit sine n pi, it is 0. Lower limit is sine 0, it is also 0. Okay, so we have only the first term. This minus sign can be absorbed here, and we can write minus 1 raised to n plus 1. Pi can be cancelled. Okay, so we have minus 1 raised to n plus 1 into 2 divided by n. Okay, n is 1, 2, and so on. Okay, that's all. Now all an's are 0 for f1. For f2, a0 is pi, all others are 0. Okay, so we can write Fourier series of f by adding these coefficients. Okay, therefore Fourier series of f is a0 of f2, that is pi, plus bn's are non-zero for f1, and these are minus 1 touch to n plus 1, 2 divided by n into, so bn into sine nx. Okay, so n from 1 to infinity. All others all other coefficients are 0. Okay, so this is the required answer. Thank you.